Hello, welcome back to Algebra 1. In this lesson, we're going to continue learning how to multiply things together in algebra. And here we're going to talk about multiplying binomials times binomials. So it's easier to explain how to do it and what it means just by writing an example down. And I'll show you how it's really already very similar to what we've already done. So if we have, for instance, y plus 3, that's a binomial because it has two terms, okay? And we want to multiply that by another binomial, and let's say this one's y plus 2. So that's why we call this section multiplying binomials times binomials. So we have two terms surrounded by parentheses times another two terms surrounded by parentheses. Now, in the previous lesson, we talked about multiplying monomials times binomials and polynomials, and we've already talked about that. So for the sake of argument, pretend for a second that this y, just put your thumb over it and forget it's not even there. Pretend there is no y here at all, and you just have the 3 parentheses y plus 2. How would you do that? You would use the distributive property, right? You would take the 3 multiply times y, and you would take the 3 multiply times 2. That's if the y was not there at all, okay? Now, and we've done that in the last section. Now, pretend for a second that the 3 was not there at all. Just put your finger over the 3. All you have out here is a y, and inside here, y plus 2. How do you do that problem? Again, pretend the 3 is not there at all. You would take the y, multiply by y, and you would take the y, multiply by 2, distributing it in, and they would be added together because of the plus sign. So separately, the 3 gets distributed in, and separately, the y gets distributed in, if you can kind of pretend that some of these parts on the outside don't exist, right? So when they do exist, like what we have here, it's very simple. You have to do both things. So when you see a binomial on the outside, you need to, instead of looking at it as one item, you need to think of it as two things that are added together. So in order to do this multiplication, what you do is exactly what we just said. You have to distribute the y in to each of these two terms, and then also separately you have to distribute the 3 in to both of those terms. So you're multiplying each term times the other two terms. That is going to complete the multiplication process. So, and there's actually another way to do this multiplication I'll teach you in the next section that you'll probably learn in your class, but this way is very straightforward because it's a direct extension of what we just did in the last section. So let's just get started here. Y times y gives you what? Y squared, because we can add the exponents. And then y distributed into the 2, and there's a plus sign here, is going to give you 2y. All right? So those two answers is just from distributing the y into each of those terms. Now we have to look at the 3 because he's also on the outside here. 3 times y gives you what? 3y. And then separately, 3 times the 2 gives you 6, and it's a plus sign, so it's going to give you plus 6. So this is the answer, but we immediately see we have y squared. There are no other y squareds here, so we can't add them to anything. We have a number, but there are no other straight numbers, so we don't have anything there. But these two interior items are like terms because they both contain y, so we can add them. 2 plus 3 is 5, so what we'll have is y squared plus 5y plus 6. And that is the final answer, so circle that. And you can't do anything more with this. You can't add any more of these terms because they're not like terms. We have y squared, y, and then just a number. Now, again, I'm telling you there is another way to do this multiplication, but it ends up giving you exactly the same answer. I'll teach you that in the next section. But for now, you need to look at any binomial out front as a collection of two items that need to be distributed in. Start from the first one, go to each other term, distribute in, and then go to the next term and distribute it again like that. If you can remember that, you're going to always get these problems correct in algebra. It confuses a lot of students, but it doesn't need to. So let's get some more practice. Let's say we have a plus 4 times a minus 1. So again, we have a binomial here and a binomial here. So each of these terms, this one and this one, needs to separately be distributed in to the second guy, and then the 4 will be distributed in also. So we just need to take it one step at a time. A times a gives you a squared. And then a times the negative 1, don't forget there's a negative 1 here, gives you negative a. So that's how you write that. Then you have 4 times the a, because we're distributing it into the first term there, gives you 4a, positive 4a, because they're both positive. And then 4 times the negative 1, don't forget there's a negative 1 there, gives you negative 4. And then we look to collect like terms. The only like terms we have are these two, negative a and 4a. So it's like negative 1 plus 4, which is the same as 4 minus 1. So it's going to be a squared plus 3a minus 4. A squared plus 3a minus 4, that's the final answer. We can't do anything more with this because this is not a like term with this or this, so we can't combine any of those final answers. All right, let's move along to the next problem. What if we have 2x minus 1 times x minus 5? So again, each of these outside terms in this binomial gets distributed in separately to each other guy in the other binomial. So 2x times x gives you what? 2x squared, because we add the exponents on the x's there. And then we have 2x times the negative 5. Don't forget it's times negative 5, which gives you negative 10x. Okay, because we have 2x times negative 5. Now we turn our attention to the negative 1. Don't forget this is a negative 1. So we multiply by x gives you negative x. And then finally, negative 1 times negative 5. Negative times negative gives you positive, so it's going to be positive 5. And now we look for like terms, and the only two like terms we have is negative 10, and this is in minus 1, minus 1x. So these are like terms. Negative 10 minus 1 is going to give you negative 11. So 2x squared minus 11x plus 5. 2x squared minus 11x plus 5. That's the final answer. All right, we just have a couple more. Once you understand the concept here, and that it becomes an extension of what we've done in the past as far as distributing these things in, then it becomes very simple because it's basically just a small extension of what you've already done. So let's work with 3 times z minus 2 times 2z plus 3. All right, so same thing. We have two terms in this binomial. This one gets distributed here, then this one gets distributed here. Then don't forget this is a negative 2 going to here, going to here. So let's go ahead and get it done. And what we have is 3z times 2z. 2 times 3 is 6, so it's going to be 6z. We add the exponents, giving us z squared. And then we have 3z times positive 3 is going to give you 9z. And then we have to turn our attention to the negative 2. This is a negative 2 times 2z is going to give you negative 4z. And then negative 2 times positive 3 is going to also give you negative 2 times 3 is 6. Now we look for like terms. We have a positive 9 and a negative 4. So we just subtract them. We get 5. So it's going to be 6z squared plus 5z minus 6. 6z squared plus 5z minus 6, that's the final answer. Now we're just going to do one more of these. Here we go. 4s minus 5 times 4s plus 5. Okay, so we're going to start with this guy. We're going to distribute to 4s. So 4s times 4s. 4 times 4 gives you 16. S times s gives you s squared. We add the exponents. Then we have 4s times the 5. So 4 times 5 is 20. They're both positive, so 20s. And then we move our attention to this. This is a negative 5 times 4 gives you negative 20s. Don't forget there's an s here because you have negative 5 times 4s, so you get negative 20. The s comes along as well. And then negative 5 times positive 5 gives you negative 25. And then all you have to do is collect like terms. 20 minus 20, these are like terms. They just subtract out to 0, so all you have is 16s squared minus 25. 16s squared minus 25. Okay, and that's all I'm going to do in this lesson. Pretty much any two binomials that you have, which, by the way, multiplying binomials comes up very, very often in algebra. But it's not a difficult task, even though a lot of students think it is, because it's basically an extension of what we've done. If you cover up one of these guys, then you are distributing the other guy. If you cover up the other one, you're distributing this one. So it's basically doing everything we did in the last couple of sections, multiplying binomials. You're just doing it more times because you have more things sitting out in the front. So make sure you can do these, that you understand the concept, practice them on your own, and then follow me to the next section. We're going to be continuing to multiply binomials, but I'm going to show you a different technique that's going to give you the exact same answer that you're probably going to encounter in algebra at some point. So we'll cover that next.